This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development.
For our finale, our grand finale for the year, we have Hiroshi Ishii from the MIT Media Lab, who has been here for all this week as a distinguished speaker for the Symbolic Systems program, and has been meeting with a great number of students and faculty from all different areas. I think one of the wonderful things about Hiroshi and his work is that it really touches on so many different things. It's very highly technological at times. It's very artistic, so he's really dealing with the arts. He's done work in looking at people and how they interact, so he's into the human side of human-computer interaction, and design as a way of thinking. We talk about interdisciplinarity, and I think Hiroshi's a great example of being able to really cut across these things, both in his own work and in the lab that he's led. So tangible bits in itself sort of suggest that, and he'll be explaining what that means and what his work has been over the years in doing that.
Great. Good afternoon, and thanks to Terry for the great introductions. As he mentioned, I'd like to thank to Symbolic Systems Programs who kindly gave me the opportunity to spend 2 weeks in Stanford, and also especially Todd Davis, he's sitting here, allow us to, me and my family, stay in his house next to the dorm. It's great. I could feel all the excitement, energy, even midnight or early morning of students. That reminded me going back 20 years younger. And the reason I'm so excited here is I'm so inspired meeting the amazing people. Of course, Terry, Todd, Cliff Nass, and Roy P., and also a bunch of the D-School people joined from design. But also I had an opportunity to talk to Doug Engelbart, my hero. Also, I went to South City to visit Ted Nelson's house. Also, Howard Rheingold invited me to Mill Valley. And also, Kevin Kelly invited to his house. It's amazing to see all the people, but they're all connected. Many are the hippie, high-techno hippie, but it's great. And they're still so stubborn and never lose the vision and passion to make a significant change to the future. I really appreciate to the Stanford University, which gave me this opportunity to get a lot of the energy. And I hope my talk also contribute by inspiring some of the aspects that you are really keen on. So Stanford already have such a strong design program initiated by Joint Program of Design. Now this school is taking the next level. So not anymore just design, but design thinking is a fundamental creative process, just disseminating entire campus. And I really appreciate all this effort. But also I really care about a bit different aspect, that's art. Because you're already good of design. So I'd like to shed the light from a bit artistic point of view. Because I've been drawing from my childhood. And even though I grown up, but still I'm drawing. And sketching is very fundamental, important method to externalize my idea while I'm thinking and talking. Individually or in a group setting, I was always drawing. And later, I had a chance to meet Bill Barplank sitting back. He's a guru of the visual thinking. He introduced me the amazing rich intellectual activity started here by Bob Mackin, all the culture of the visual thinking, something very fundamental. And so speaking, gesturing, pointing, reading, writing, draw, spontaneous improvisation, something important. This is the opposite of highly structured, prepared PowerPoint slide projected onto the screen, which does not invite you to mess up or add or edit. So I was interested about how to really use this important visual thinking over distance, because at the time I was working for NTT, telecommunication giant, who were so eager to promote broadband ISDN. They are so good at to make a highway to transmit the bits, but there's no idea about what car should run, what service traffic rule, what community should build around the highway. So we try to contribute from the contents. But at the time, there's no digital network or codecs which fast enough, no flat display. So we have to emulate future by just using analog video cable. But I'd like to show the recreation of the early prototype. The work was done in the early 90s. So this is a version we recreated for the exhibit in 2000. You can see the drafting table through which my partner can see me, but also he can read my gaze direction very precisely. This is beyond the eye contact. So drawing is very powerful. Sharing sketch is very important, but also eye contact, facial expression is very important. So we try to connect two entities, that is interpersonal space and shared workspace in a continuous isotropic ways. Current video conference still have a thumbnail, a post stamp size like talking heads, disconnected from the shared drawing surface by digital. Even though this person is drawing this one, mouse cursor doesn't convey any power of the communication. So I'd like to extend the architecture space with any distortion, having shared workspace as a connectors. So interesting, in 1994, I got an email from Alan Kay, whom I never met. Of course, I knew him, but I got the email from him, and he asked me to give a talk in Atlanta in a Vanguard conference in 1994. Then I went to the conference, I gave a talk about career board, also future visions. Then in a coffee break, Alan Kay and Nicolas Negoro-Ponte came to me, suggesting me to come to MIT. So after 10 minutes of the break, I decided to go there. So that's the beginning of the dramatic change. But I never studied. I never lived in the United States, and so it's very kind of high risk, kind of interesting challenge. MIT is actually like a zoo. It's very complex. But I was naive enough. And also another amazing requirement is reboot. Nicolas asked me as a condition to reboot, not continuing anything I've done before. Life is short. It's such a luxury to challenge completely new stuff. So I took this literally, then stop the CSCW work or video mediated communication, then starting exploration of the new field. So I'd like to talk about the story of my struggle to finding out the new interesting problems. Then I'd like to show how I tackle these problems. So my research is a kind of part of the effort of the bridging physical world and digital world. Many people now work on this field, like ubiquitous computing, large, is all this effort, pervasive computing. There's a lot of the technology now enabled to connect the physical world and digital world. But I have a specific interest about hands. Visual thinking is great, screen is great, TV is great, but fundamentally visual is extremely good when people passively absorb information as photons that hit the retina. But all you creator, designer, researcher have to externalize your idea to communicate or reflect on the externalized idea. To do so, you have to use hands, body. If you're a musician, composer, you have to play piano using your body. If you're a dancer or a choreographer, you have to use your body to express and test. And if you're a designer, you have to sketch. So how to really fix the imbalance of current computer-human interaction, which is so focused on the visual output, was one of my motivation. Also, I was very much interested about the meaning of digital computation. To understand the meaning of digitals, I went to the Museum of Scientific Historic Instruments, which full of the beautiful artifact which represents knowledge, like this one, which abandoned because everything replaced, emulated by computer, pixel on the screen. But these artifacts has amazing beauty, aesthetics, craftsmanship, materials. More importantly, teacher and the students put their hands on the crank, then rotate through all the kinesthesia, body as an engine. You really understood why there are 4 seasons on Earth, or why solar system is working. And understanding of this kind of spatial, complex kind of stuff really requires the having bodies as a part of the equations. Hands have to also help to think. So aesthetics of these artifacts and the joy of haptic interactions should be connected to the digital computation. That was the beginning of my thinking in 1996. Another important artifact which inspired me is always I go back to my childhood. What captivated me? One is drawing. Another was abacus. So I already had a kind of partial answer at this age of 2 years and 7 months old. But how many of you compute with abacus? Oh, good. A lot of people, yes. Abacus has very interesting implication. First of all the information digits are represented as mechanical beads, which you can directly touch and manipulate. Of course, it's no surprise. But no separation between input and output. I/O coincidence. No separation of the control like a mouse and the representation like a pixel. That is something fundamentally important. Second, transparency or affordance. There's no silicon chip made by Intel or other company. Everything is transparent. You can really decode, understand all the stuff, memory, input, output, computation, everything is exposed. So you can do the qualitative reasoning to understand all the process or internal states. But current computer is fundamentally black box. Even if you have a microscope, you can't really decode, reverse assemble all the moving photons. Because this black boxness makes the situation very complex. So also abacus has a great affordance. If you grab the abacus, that can be, for my kids, musical instruments or toy train, and also you can scratch your back. To do so, you don't need to read the manual. This is something fundamentally important. People already have amazing knowledge about world, body, and the space, but we abandon this one. Then we enforce people to learn very cryptic, arbitrary language designed by certain engineer. And so I thought there's something we can do it. Then the idea I came up 12 years ago is very simple, physical embodiment of digital information. In other words, give a physical form to digital information by tight coupling, real-time coupling of sensing and also the feedback. Having said so, it's very difficult to convince this has any value to pursue as a research domain. But one important constraint is if I do anything incremental, dead end, I can't survive in MIT. Maybe Stanford might be also same. And so we are strongly encouraged to take a high risk to starting something very different. So ambient media is one of the examples of the spin-off from research. We are spending so much time in front of the computer screen, but nature is full of the beautiful media, which does not take so much your cognitive boundaries, but still you can get a lot of the meaning. You can do a lot of the parallel processing because the brain is an amazing parallel processor. You can tell change the weathers or the sound from a kitchen, tell you that the lunch started, and also the sound of the conversation or smell. Many things telling about the changing situation in a very soft, gentle way. So we pick up the wind as a first example. Then we implemented a display for solar wind. I had a lab to the solar system. I wanted to feel the heartbeat of the sun in my laboratory. So this is a spin based on data we collect from the internet. So it's blow as a wind. It doesn't distract your foreground conversation, but you can always feel that is something going. But our sponsors in the media didn't like anything about solar wind. So now they're spinning based on NASDAQ, Dow Jones, stock exchange volumes. And it's okay. It's sponsor is important because I have to pay stipend tuition all my students. But the most important thing is not the contents, but the way we can present information. Now, many people really try to use computer for cellular phone, everything. But both computer and the PC really requires foreground attention. You cannot really do stuff subconsciously. That really requires so much attention, but attention is the most scarce resource. And so how to really rebalance the foreground and background is one of the important challenges behind that. And this became interesting products like ambient orb. How many of you seen the ambient orb? Great. Ambient orb is a great way to let people aware about the subtle change of the informations. And one of the best example is in California, big electric power company distributed thousands of the ambient orb to the big office or factory. To prevent from making another power plant for the peak traffic of the electricity, they control the price in a very fine granularities. But the people have no attention to check, now it's just 3 p.m., so price is 25% cheaper, so maybe I should start something. So just having the light change the color, or maybe it's a good time to start washing, or let's wait, so that you can contribute not to increase the peak traffic, but also you can use the energy which cannot be stored in the evening, for example. So these are really interesting examples because we learn so much about human perception. But also I want to bring the new dimension which is different from a foreground-centric computer cellular phone. So here I'd like to just illustrate what is important component which drive design, creation, or research. And of course, technology is something fundamentally critical because that enables something which is just impossible before, like internet. And also users' needs is something very important, and especially in the HCI field, usability evaluation is most important. If you don't do any usability study, if there's no user task or evaluation, you never get the paper accepted for CHI conference. And that's important. Also, they think this is a human-centered design. And, this is certainly a very important goal to make technology usable for the people who have some problems, who have some request to improve it. But sometimes quantum leap of the innovation does not come from the ethnographic study or interview. It comes from mind in a people like Doug Engelbart. He's my hero. And so these are not necessarily driven by needs finding or user study or evaluation, but it comes from the art. For example, art inspires people, makes people think differently. So I do believe there's a layer like a vision or concept which really drive this kind of thinking. And of course, it's very important to think about the lifespan. The reason I really care about vision is technology become obsolete less than 1 year. And all the applications also gone in 10 years, being replaced by other stuff, say music, LP, CD, and MP3. But also next generation of kids have totally different skill or social protocol. So nothing can remain more than our lifespan, except for the vision. So I'm now enjoying the research in academia so that I want to create something which can last much longer than my lifespan. And that's the reason I really focus on the vision. Having said so, vision is very abstract, almost like a philosophy, a theory, unless you translate into the concrete instances of the application. You cannot communicate it. So that was the struggle for first 3 years. So I'd like to share some struggle. And then we found the first killer application called UP, urban planning. Then later, it's very easy. Now people understood the vision, the worth studying these kind of visions. So applications themselves have own like benefit, utility, user, task. But the most important thing is each application shouldn't be micro word, closed micro word, but have to support higher vision. So we developed many applications. But the most important is how you came up with this idea. What kind of the underlying principle or philosophy is there? So that is tangible. So I'd like to show several examples. One is a touch. Touch is such a fundamental way to communicate. How many of you have babies now? Good. So communicating with a baby is so wonderful, but the sense of touch is something so fundamental. Reach out and touch someone is a great copy that the AT&T group used almost 30 years ago. But unfortunately, TV commercial was a video phone. Touching video phone screen doesn't make any sense. So we came up, Scott Brave and Andy Daly came up this idea of the InTouch using a 3-roller device, but each roller is connected by mathematical spring so that you really feel all the resistance. So this gives the illusion as if same physical objects are distributed, they're a copy, but they are connected. By interacting, mediated through physical object, you can really communicate, express your emotion using a sense of touch. This is a bit like a tone of voice. When you have a phone conversation, you can really communicate the subtle nuance, emotional aspect by the tone of voice. Same thing is also possible with touch. But touch is great, only 8 kbps bandwidth, but you can really express a lot of stuff if you are in an intimate relationship. And so we are very excited about also fundamental engineering principle is very simple, synchronized distributed physical object. That also helps later to develop many other applications. But these are technological principles. More important stuff is concept, vision. that is ghostly presence. Community in a telepresence or telecommunication worked so hard to make remote parties is as if sitting in the same conference room using a visual and auditory channels. And they believed that if you feel that all the partners in the same room, you can have a productive meeting. So, but the boring meeting is boring meeting in spite of the remote or collaborate. And so we came up with the idea that the current interface is like that. Always your partner is behind the screen, even large screen. So why don't we use the object moved by remote partners without representing the body visually, but high quality sound and the object by moved by people evokes the sense of the ghostly presence. So you can imagine the body if you know the people. So it's like a player piano. This is a half crazy idea, and the paper got rejected by science community because it's not scientific. But the media arts community liked it. So many artists started a lot of interesting haptic remote interaction artifacts. It's great, but they don't publish. So later, those people told me in a party in Ars Electronica. But that's an interesting experience for me. So ghostly presence is a bit in a Zen-ish without representing how to represent the existence. So this kind of thinking is something we enjoy a lot. Caribot is another example. Phil Fry created based on the in-touch research. Instead of real-time remote communication, here you record all the motion. This tiny robot play again and again. So this was meant to be the tool to teach differential geometry. So we can ask kids to draw star-like shape. Then kids move Caribot in this way and rotate certain angle. Repeating 5 times, the star is drawn. So this really helps a lot of interesting thinking. But this was inspired by turtle graphics of logo language, which Professor Seymour Papert invented many, many years ago. So this also led to the next invention done by Hayes Raffle and Amanda Parks called Topable. And actually, Amanda came from the design program of Stanford, of the Mickey, and but she also was a great designer. And Hayes was a sculptor from Yale, but also have a strong technical skills. So here you see a system called Topable. Topable has 2 types of genes inherited. One is a recordant play, which came from Caribot, you've seen it. Another gene is constructive assembly. Everybody loves Lego blocks. And Hayes Raffle was a key creators of the Zoob. So Zoob also allows a lot of interesting complex structure. So constructive assembly, passive one, plus active component is very important. Here, this is a grammar which is based on the study of the crystal structures and also human and animal bone, like a Fibonacci ratio. This is an active component, have a sensor and a memory and a microcontroller which record any motion. But connecting these 2 different types of stuff, you can really sculpt a lot of interesting kinetic active motion. This is very different from top-down humanoid robot design. It's more bottom-up, like a building block. You can design variety of the interesting stuff. Now you can introduce higher concept like a global controller called Queen. Queen controls everything connected in the same network. And also later we introduced the backpack, which allows phase shift or attenuation. So here you see every movement is synchronized with the movement of the Queen. Here you see the phase shift, you see some delay, which make a more snake motion. So these concepts are quite complex. And when they come to Stanford or MIT, they learn everything mathematical equation, symbolic representation. However, we feel hands-on experiences with this toy at the kindergarten or elementary school may help scaffolding about these concepts, center of the gravity or torque. So this kind of inactive experiences with hands-on objects may help to people make a jump to the symbolic representation or learning. We've been also working a lot about the table because we love table to work. So John Dagofra, who got the PhD from my group first, came up with the idea of the new light bulb. This is also the concept or vision. So light bulb can be explained as a video projector, but 1 by 1 pixel. So he came up with higher resolution light bulb, but also 2-way, bidirectional. So basically, camera and the projector pair, collecting all the photons, then interpret the array of the photon using domain knowledge, then compute digital light and shadow, then project them back to the real world, so that you can give a new life, meaning to every architectural membrane. So I'd like to show the first application which convinces people, okay, that's something. So I'd like to show the
is our most complex
urban planning
application to date, and is again intended for professional use, this time in the field of architecture and urban planning. ERP employs wireframe architectural models as the focus of a number of integrated simulations, including the generation of accurate shadows. These projective shadows are carefully aligned with and permanently affixed to the base of each architectural structure. A kind of inverse clock can be placed arbitrarily within the workspace and adjusted to control the simulation's current diurnal time, in turn controlling the sun's position in
So
the sky.
people have been using
Here
a
are
physical
West
model,
48 clock
scaled
shadows
model
shrink
of the
markedly
real
at noon,
city,
and eventually
thousands of
swing around
years.
to the east
That's a
as
very
time approaches sunset.
simple and clear way to
Ability
represent
can be
and
applied to
communicate.
shadow studies.
Today,
Based
all
on
the great
architecture
CAD
urban planner
software inside the
responsible for the new
computer
structure on the
screen
right must
is
worry that it may
disjoint from your
exclude the
body
existing
space.
left buildings more
Also,
sunlight.
very
It
difficult to
does
work
this position,
collaboratively
but
as a
experimenting
group
with
of
possible
people.
solutions simply means
So
grabbing
instead
the
of
building
diving
and
into the
trying out new
computer screen,
locations
we
or
brought back
orientations.
computation back to
Four-lane
the
roadway with
architectural
simulated
work
lots of traffic
table
provides the context
in
for the next
combination
function.
with the physical model. In this case,
Material one can be used to change the
framework
surface of
models.
any building from
This
brick to
shadow is
glass,
computation
after which
shadow,
the
of
building
course.
produces
So
not only
combining
shadows, but
rigid
also solar
atoms
reflection,
as a
acting
tangible
as a
grasping
time
handles
structure
and augmenting with the digital
Simulated
shadow,
reflections
you
whose
can give the
behavior is
illusion
quite
as
unintuitive
if
can aid the urban designer in
the
checking
building
hazard
model is
situations
casting a real
in
shadow.
which low-angle laid
And
after
also you
visual
can do a
work
variety of
like
simulation, for
permanent
example,
air
wind
vector fields
flow
provide a good
simulations
qualitative impression of the
or
overall
simulation of sound.
anemometer like
Basically solving a Navier-Stokes equation. Every time you move the building,
any
the
particular
boundary condition changes. We are recalculating. But the visually representing, you can really explore a variety of possibility. And this communication is very different from PowerPoint slide like this one. These are dead ink, optimized for my presentation. You may not trust my point, but this document is democratic. Simulation of Navier-Stokes equation is running. Then everybody can grab the building, then try out what happens because space multiplex inputs. So that really make much more easier to people participate, then try out variety of idea. So that's one important theme. We also apply for many business simulation using system dynamics for supply chain management, event-driven simulation for network design, but always participatory design around the table make a big difference. Let me show another example.
light system, and is the first step toward building an entire luminous room, in which every room surface is capable of display and interaction. Here, a laser model is pointed so that the beam shines off the workspace surface, but a second surface picks up the beam, giving rise to an expanded available workspace.
So
As you
important
can see, our
things of
intrepid optical
the
engineers are
power of the
collaborating to build a
metaphor,
much larger
light
hologram
bulb,
setup.
is kind of critical for
Ordinarily, we would
PhD.
directly abut the two
It's of
workspaces
course,
to simply
camera
position
and the
workspace
projector
environment.
pair, but using a metaphor of the light bulb, people can easily imagine
Tables separated.
Stanford University may have 10,000 light bulbs. What happens if you replace all the light bulbs in a class or your studio to the I/O bulb? Then you can give any new digital meaning to the manipulation of the object. Nothing happens if I put this bottle here, but maybe bottle may cast digital shadow. Then this bottle may mean something new, for example. If I have so this is a great way because a bunch of the I/O bulbs communicate and coordinate so that you can extend workspace infinitely or replicate, then synchronize. So this conceptual tools, like metaphors, like a light bulb, is very powerful. So that's something to do with a vision. Objects are great, but relatively passive. They are waiting to be grabbed. That's not so exciting. So actually, Manzi, you here? Oh yeah, he did a critical contribution to this project called Actuated Workbench, and putting many magnets together. His team and John Pangaro made the object dance. Here's the anti-alias smooth movement. And also you can think about many applications to predict the future, whether you can finish a PhD within this year or your Kai paper gets accepted or rejected. Anyway, so this brings the new dimensions. Then Manzi and Jan did this simple but powerful demonstration of remote collaboration. This is a ghostly presence, high quality sound, and shared workspace. So this is a solar cellular tower optimization problems, and the people are moving the tower. But the interesting things happen when remote partner grab same tower that you are grabbing. You feel the force. So this is like a in touch, like interpersonal connections. And also, Manji put a digital shadow to strengthen the sense of the remote presence of the body. So this is a ghostly presence. People use telecommunication to get job done. Maybe in the beginning and they want to see each other's face, say good morning or we've done good job. However, the workspace is more important. So it's an interesting possibility using actuation. So now I'm very happy to present one of the latest advancements beyond actuated workbench. I've been thinking a lot about the visual thinking and also post-visual thinking is something we call tangible thinking, using a physical object while manipulating, but associating objects into the abstract concept, what people can do. So this is James Patton's PhD thesis. Then problem domain is optimization of spatial arrangement of a cellular phone tower. Bunch of towers are moving because he's moving the map or scaling, but also computer is continuously recalculating to optimize, finding the best location. So it's very computationally heavy problems. But now he puts his hand to slow down or stop the computation in certain area. Putting the weight really slow down or stop the computation optimization in certain area. So now he puts a ring so that it constrains the space this tower can go. Next, you see the skirt, which constrains that two towers cannot closer than, say, 3 centimeters or whatever, 2 inch. Okay, yeah. So this is a language which does not require a PhD of computer science from Stanford or MIT. Everybody understands. This is a mechanical language. So that's an interesting jump for us. Once computers start representing, manifesting their computational state as a mechanical, physical movement of the objects, then user can easily intervene this movement using everyday knowledge. So we started to explore a variety of the language and the grammar to allow people to interact with computational stuff. Before this interface, you have to go back to the editor, Emacs, read the source code, recompile. But here you can just put the weight to slow down so that you can give more computational resource to other place. Or you can also easily define the expressional case because Mayor wants to get a better signal so that you can bring the tower to close his house. Also, if you want to accelerate the computation into certain area, you can use a high-tech called SOAP. So this SOAP allows you to give more power to this tower or area because more computations moves in relative to other places. So this is very important turning point for us. Representation matters so that people and the computer can collaborate. They may not understand each heart or intention. However, representation it has great impedance matching with what people can deal with using everyday knowledge. So we are very excited about all the possible language or grammars or vocabulary which enable people to interact with computers. So this is an important way to enhance the thinking or collaborations. And we are also very seriously thinking about material for thinking or representation of idea. That's something very fundamental for creative work. Illuminating clay is a project that Ben Piper started for master's thesis using inert clay, but the laser range finders capture the geometry, make digital elevation models, then apply all the great algorithms developed by the community of geographic information space, then projecting back to the clay. Then all of a sudden, inert clay like this becomes real computational media. You see the elevations. And also, next you will see the water drainage as a vectors or shadow simulation. So let me jump to the portion.
So using the DEM, we can analyze the model in a number of other ways. On the top of a mountain, and the cursor over the center of the model here.
So Ben is explaining about the system, and he's going to choose one mode called water drainage.
the numbers that you see are indicating that
designer want to give a beautiful scenery. So artistic expression of form giving using clay is one important thing.
For example,
but simultaneously, it's also important to make sure that this landscape is implementable or economically feasible. So this water drainage mode gives you about insight how water runs down the slope. So this vector shows the directions. Also color shows the speed. So that implies erosion. This is a really 3D tangible representation.
We want to look at how
and you can
insertions in the landscape
easily explore the variety of the possibilities by this is a computer screen, bird's eye view, vertical screen. But in front of this screen, you have a real tangible representation. You move all these objects so that you really know how the bird's eye view will change. Current interface does not have a tangible representation, just everything virtual. So having this one as a common ground among groups of people, the collaboration, communication, coordination would be dramatically different. So we got the commission from Ars Electronica as interactive art piece. But there's a financial constraints to buy a laser rangefinder. So we devised the new technique using a half-translucent optical beads and IR light shining through. Here you see the water drainage and the elevation again. But using camera, you can capture the height of the hill. So people can manipulate the sand. Sand is much more fun because much more malleable. Also, everybody used to be the kids playing the sandbox. And in California, also, we found some store like a Nature having a small sandbox for the executive of the startup company who are so strong under pressure to calm down. So it's great. Playing the sand always brings a peace of the mind. But this is not just sculpting sand, but also giving important information for design. So I think this is very important because in the early stage of design, ideation, physical materials play a very critical role. In the case of the contemporary architect, Frank Gehry, he extensively used object, graspable object or found object. The important point is there are two different worlds, physical and digital. Both have a strong strength and weakness. But unfortunately, current design, you are forced to choose one out of two. Then all you have to go, the scanning or printing to go back and forth. There's no real-time synchronized mechanism. That really makes life more complex. So our challenge is to try to make a new media, tangible media, which inherit from both worlds, physical world, so that it's afford sculpting using your hands, while you can also benefit from computation analysis and the reflection. So sculpting, form giving, ideation, and rigorous analysis is not anymore separated. So hope this kind of creation of new media may help artistic exploration, design, and engineering analysis. And also, this really corresponds art and science to my eyes. So we are very interested in building a new materials or media which helps all this process, combining both. And another example is ping pong plus. How many of you play ping pong? Oh, a lot. Amazing. When do you study? How many play seriously ping pong? Oh, nobody? Okay. So this is, you can see the digital water covered on the surface of the table, or you can create a lot of interesting augmentation. The reason I started this project is I was interested about to explore the competitive nature of the ping pong versus collaborative art, because ping pong is very competitive to make your opponent make a mistake. It's a very kind of horrible like stuff. But once you augment in this way, even you make a mistake, then ball hits the net, you can still enjoy all the water ripple effect. But the real story is when I came to MIT in 1995, I was very shocked. All the students are much better than me. Manzi is amazing hacker, both electronics, computer. But basically, every student better in C++, electronics, and machine shop. No way to really compete with them. But I have to gain respect to be a professor, to start a new team. So I bought an Atlanta specification Olympic ping pong table. Then I played seriously with all students. Then they started respecting me. So I made a team. But the problem is I use the research money, research fund for buying ping pong table. Then I face another problem to justify the expense of the research academic money for ping pong. Then we put the 8 microphones beneath the table. Then each microphone compares the time when he has the ball hit sound. So we can do triangulations. Then we create a variety of the application. But also there is a great bonus because this project became very popular so that many famous museums of the contemporary art, like Centre Pompidou, and also Victoria and Albert Museum in London, invited us as artists. It's nice, cool to go to Paris or London as an artist, although I don't know what means artist. Also, best thing is even you have a power outage, still people can play. This is seriously important. All your digital application or net application is gone once you lose the power or a computer dies. However, this ping pong table is still a ping pong table without electricity. App is also same. Still building model makes sense. That's something profound. Persistency of the physical existence object really gives a very different sense. But we really enjoyed through this project. So also another important discussion we have is many people talk about invisible technology or translucency. And so I had one argument against that. My ping pong paddle co-evolved with my life. Using more than 20 years, it's deformed. You see the grip. So because it's made of soft materials, through many, many years of hard exercise, although I was not so good player, but it's changed the form, then really fit nicely to my hands. Then in the end, become completely invisible. When I move, then hit the ball, I don't need to calculate about size of the paddle plus my movement is enough to reach the ball. I just subconsciously move and hit. So this completely disappears as a part of the body. That's one ultimate state of the computation tool which disappear or become invisible. But on the other hand, ball has to be visible. Also, table has to be visible as a reference, or your partner has to be also visible, because that's the main representative task. So making everything invisible doesn't make sense. If most important things are represented in digital pixel, it got to be foreground. And if not, it's just a tool. It should recede back to the background. But also another challenge is we are juggling so many tasks, multitasking. Then our attention is so limited. How to make smooth transition of foreground and background, changing representation is something important challenge which nobody have really solved in an elegant way. So ping pong taught us a lot, but it's also a lot of the fun. Also another fun example is the music. How many people play computer music? Great. If you go to jazz concert or classic concert, you clearly see the trained musicians interacting with the acoustic, mechanical, musical instruments. Then you know the causality chain of sound is coming out from the interaction. Unfortunately, in the most cases, computer music is laptop computers. All the musicians bring laptop computer. In a crowded hall from the distance, you can't tell if this musician working hard or doing email or everything pre-recorded, just hit the play button, then doing an eBay, for example, or Facebook or whatever, or Google. So lack of the legibility of the causality make performance less exciting. So James Patten and Ben Lecht created this system, new graphical language to decompose the computer music in a dynamic graphics language. But here you see the blue object. This is a microphone, but the virtual physical icon to represent microphone. Then you see another pack represents source of the variety of sound, determining rhythm or tone or bass or whatever. Then two musicians use 2 hands, means total 4 hands simultaneously to change variety of the parameter on the fly. This is very computationally heavy, intensive stuff, and also user constantly change the parameters. But the projecting this image onto the screen, people can have much better understanding what's happening inside of the computer. In the beginning, I mentioned about the black boxness of the computer really makes things illegible or complex or not so exciting. So we're interested about the challenge about the experience of this kind of performance, bringing a tangible interface and also new graphical language like you see here. So Another example of the artistic project we've done many years ago is the music bottles. One of the important key strategies of tangible is you can invent completely new language like a topobo. That's one approach. But also you can take another strategy to analyze the everyday physical object that the people already have a deep understanding using 1,000 years. The bottle is an example. So a bottle is a container. So we try to push the meaning of the container to digital domain using a minimal design. So it's like a perfume bottles. You open it, then contents coming out. Can be radios or music or speech. So fun thing of this project is our friends could play music to record it, but also we couldn't find the right bottle. So we went to the glass blowing studio to make many kind of glass, then breaks, and also like a sand frosting. So a lot of the interesting subtle expression. All the photons dance in a thin frosted glass. That's totally different from the pixel you can fully control as a programmer or God. Also, fragility of the bottle is something important, like our life. We already lost several bottles by dropping because of gravity. But once you drop, it's over. You cannot reuse it because all the tuning is out. So this fragility really gives a sense of the aesthetics and the emotional experiences. It's not simple on and off switch or mute and play switch. How the experience reach out and open the bottle is totally different from simple clicking the mouse. So this project started from very personal reason. I had a dream to give a gift to my mom because she was interested in knowing the weather forecast. Every morning she wakes up, she waited, she sat in front of TV. So this bottle, instead of watching TV, waiting for the weather forecast, I wanted my mom to open the simple bottle. This is the weather forecast of Sapporo City, my hometown, north part of Japan. And I never wanted my mom to boot Windows 98 every morning and starting Internet Explorer, then grabbing a plastic mouse or clicking, because this is completely irrelevant to her life. But she passed away 10 years ago. Then I started thinking about what we can do for the rest of us. We are the kind of technical nerd. We can't live in any room without Wi-Fi in the air, like oxygen. But many people never touch any machine, any cell phone, any computer. But they have a still beautiful understanding about the real world. Why can't we design on top of that, other than forcing other people to run cryptic command sequence, like an Emacs sequence or Control-Alt-Delete of some software. So that's one of the challenge. So in the end, I'd like to show another example how art inspired our creation or design. Also how we can return back to the art. So that's something very important. This is nothing to the needs-driven design or utilities. Although application can be usable for something. So Kimiko Ryokai did this project called Airbrush. The point is, painters were also color makers at the era of Renaissance. Today you paint with the ink you are given, you purchase, or Microsoft Windows provides through the color picker. But painters in the Renaissance era went out to studio looking for the stone or clay or sand or flowers or trees or grass to find the right color. So every color had a meaning, context, and story. This is for most creative people, say kids. Kids love to tell a story. So this brush allows you to really correct the color, texture, meaning, and the story. Then you can weave. This is a very special color. It's not RGB, dry number. The meaning and the story.
S'il vous plaît.
So one of our hope is how to change the perception of the people about the world. How to let them know about the amazing possibility of the new creative expression beyond current ink and the brush.
S'il vous plaît.
Of course, we are using technology, so you can do anything. If you go to Whole Foods market, you see a lot of the fruit, but not just for eat. These fruits may inspire the kids to come up new painting, new meaning. So creation of new meaning out of the real world, like a fruit, is something very important. Also, animation becomes very simple. Just relative motion, the brush and the object, or brush and the screen. You don't need to do any kind of scripting. So how many of you paint oil? Oh, good. Oil or water? Oh, that's great. Also, Terry, you also doodling. Great. Everybody paint, and painting is great. But one thing which never changes is it's a dead ink. Once you paint, ink is dead. From the era of the cave paintings, 4,000 or 6,000 years ago, the ink is dead and stuck in the 2D surface. So I'd like to show first what our future customer, yes, they liked it. That's important. So then we could pass the test of the Kai. But anyway, important thing is the implication to the artistic expression. So next you will see the history. So please see, you see teddy bear from which this ink came from. So IO brush constantly capturing all the streams of video. So even before you paint, it can capture the history from where ink came from. So this is a new axis, say z-axis or third axis, which never existed in the history of the 2D painting. So we are very excited because we believe we make an interesting jump or leap to provide new artistic expression. So we are so excited, so went to the kindergarten telling kids about importance of history, but she doesn't care history. She doesn't care temporal dimension. She invented her own meanings of this axis. So important thing is we love art, but also we speak the language of technology. So this is a great opportunity that we can really create new materials, new clay, new paint brush, new way of thinking, which really enhance the creative thinking. So she got a PhD because not IO brush, but a more meta message. That's a vision. The world as a palette. Once you paint with IO brush, the world will be different. Once you open the bottles, every bottle surrounding you, stimulating you to fill in the contents using your imagination. This inspiration is something most important. This is not utility, not a needs, but a different dimension. So today I talked about the tangibles, very simple idea, physical embodiment of digital information and computation. It took many years to convince people that this is something worth considering beyond the pixels. But I was fortunate to be able to amazing students and artists and designers. So in a meta sense, reconciliation of a dual citizenship in the world of bits and atoms. This makes sense in the art community, but the science community, it doesn't work so well. But the more important thing is science. Still, we are grounded to science called HCI. Of course, there's an argument, is HCI science? Is computer science science? And Terry said no. Also, Marvin said no. But anyway, you have to ground in science community to survive in MIT. And, but also great that we can represent our idea speaking a language of technology, computer science, electrical engineering, mechanical engineering. But these all means, just a means. So many great students have amazing skills. But once they encounter the interesting concept, the vision to materialize, then these technology really blossom. These kids really make amazing stuff. And also really appreciate industry design community. That's the best community which trained us. Bill Morgridge has been a great mentor for many years. Also Bill Parplank. And product design community cares three things: aesthetics, creativity, and utility. So I think a really nice balance. Also media art community like Ars Electronica really helped shape our idea beyond artifact, because they try to understand the meaning of the artifact in a more historical, cultural human point of view that really expand our space of thinking. So I think as a whole, we really need to challenge to come up interesting visions. Then HCI really contribute about interactions. But through the interaction, I want to inspire people. I want the people to put the new eyeglasses. That's a metaphor I use. What I'm doing, basically I said I'm making eyeglasses. Through interacting with my pieces, I hope all the people are wearing new eyeglasses subconsciously, through which people can see something they never seen before. So that is all about inspiration and the imagination. So I went to the Florence this April. How many of you went to Florence? How many went to CHI, last CHI? Good. Last CHI was in the Florence. The same theme as art and science. But there aren't so much discussion about art. Main discussion is usability evaluations. But Florence is amazing. It's already 15 years old, but still shining. All the sculptures of Michelangelo and the architecture and the paintings still inspiring other people. Why? Maybe this is driven not needs or usability, but from different dimension. So importance of futures. Future of the 500 years future, still these are shining. So I have to think about the future. So my concluding slide is first, me talking today, 2008. I really appreciate to Symbolic System Program, also Professor Terry Unurad, who gave me the opportunity to share stuff. But the more important thing is, I'm gone in 2050. Definitely, this is 100% sure. But one of the students asked, Professor Ishii, why you are in the plus coordinate? Can be minus. So it depends on my behavior. But either I'm gone. Yeah. But the more important thing is, we are all gone in 2100s. So the other question is, thinking about Florence, what we can leave for the people who live in 2200? That's a question I ask to my students, also myself. My time is running out. I envy all the students who live much longer than me. But anyway, we have to leave something, a creator or researcher or artist, whatever. So how do people in future may remember, or may not remember, but appreciate something you leave behind it? So that might be a very crazy kind of idea, but that drives my work and my life. And memento mori is something very strong, but important message. So we have to do something. We have to leave something for next generation. So thank you very much for your kind attention. So I speak Fortran, Algol, PL1, Pascal, C, many languages, so also Japanese, so yeah. Okay, yeah.
I wanted to ask about cameras. So it sounds yeah, cameras. It seems like a lot of the technologies you use rely on camera systems to kind of create a model of the physical world and bring that into the digital world in some way. So I wondered if you talked with like film people. Do you see what you're doing is introducing a new language filmically that bridges between like artistic languages in material worlds and those representations in digital domains?
Definitely. We have a lot of interaction who create the movie and the film. And the best example is John Underkofler, who did the app. How many of you seen Minority Report? Great. John Underkofler went to Hollywood, became a science technology advisor of Steven Spielberg. In that movie, you've seen a lot of tangible representation, and also ink, and also gesture language. So that is the best way to influence many of the thinking to the movie. So one of the lessons we learned is, if your paper gets rejected by IEEE or ACM, go to Hollywood, make a movie. You can make a much more stronger impact. So after a movie, SIGGRAPH is full of the Minority Report-ish installation, but we've done much longer, much before. So that's cool. But I think a camera is only the one instant of sensor. Now sensor network is amazing. You can collect all the information. So how to really aggregate, then extract the information from data, the meaning, knowledge, wisdom. So we have full of data about environmental impact, but we still don't know the causality chain. So that we cannot really assess my action, turning off the light, really contributing, or it's better doing other stuff. So I think there's a lot of a challenge. So camera is one example, but the whole sensor network, including camera, photons, and analyzing the causality chain using model as a way to predict the future or assess your action seems to be something very interesting, challenging problem. Yes?
I was wondering, have you tried working with people who work in really abstract domains like set theoreticians or like working with like mathematicians or people who
yeah, we have a lot of the philosopher because of and the talk is very abstract language. So we talked to those peoples, and but the important things of tangible thinking here's a Moleskine notebook. Here's my pile of the business card. So this is the MIT, and this is the interest sponsors. So I try to make a bridge of the industry collaboration, but it's very tough to support it. Then some people say, okay, why don't you put another supporting tools? So what this mean? Once you map the financial state or political instability into the physical object, then represent, starting manipulating, you can really go to a very interesting dimension of thinking. So one thing I didn't show today is I use a system dynamics to work with a sponsor to solve the supply chain management problem, in which one person responsible for the factory production, one person interested about the user demands prediction, some people responsible for inventory in the warehouse. So moving all the pack, you can really do a lot of simulation using system dynamics. But they went to the lunch. Then all of a sudden, coffee cup or pepper stuff become my inventory, your invention, whatever. So once you attach very high-level abstract concept in the physical object, you can really start thinking with the kinesthesia and the body and the space without even computation, video projection. That's something very exciting, which I call tangible thinking. And the Lego Serious Play is one of the very interesting commercial service that the manager use Lego blocks to think about something very complex. But with digital augmentation like a sense table, I'm sure we can do many another interesting jump of thinking process. So connection of the manipulable tangible object and the abstract stuff seems to be something very interesting future. Yes?
Many of sort of the domain examples that you used, urban planning, cell phone tower location optimization, watershed construction and analysis. The situation sort of puts the user in sort of a Gulliver-like situation, only it was always Lilliput, in that they were the big Gulliver in a small world.
Yes.
Have you looked at how the tangible vision applies when the domain is in the real world? It's on the street, literally, and augmented reality sort of addresses that. Even things like geocaching address that. Is that a different, qualitatively different, or what?
I don't think it's continuous. So many augmented reality stuff went out of the building and studio. So entire city is a place. You can really have a digital annotation, augmentations. And many people now using GPS context-aware, position-aware handheld device. And we also lot of the great practical application and art. But I don't see elegant continuity of this device or bits and the physical context. So we are still struggling how we can really scale up into the entire city or more region. But certainly we'd like to challenge to go beyond current mobile location-based like a computing to bring more nice blending or marriage. So one of the examples is a soundscape stimulated us to change the entire dune in the natural landscape to musical instruments. All the people running around, but also wind can change the geometry. Then using a satellite-based laser range finder whatsoever. So we can create very interesting stuff because sound can be the input, but we can make any feedback. It can be music or simulation. So we have a lot of the half crazy idea, but the many stuff sounds like a bit art project. So also I want to show some practicalities in addition to the artistic aspect. So give me 5 more years. Yes.
You said you used a term called affordance.
Yes.
What can you explain that? Because most of the stuff that you've done is not affordable, clearly.
Sorry.
Right today.
Sorry, by affordance, I'm not in financial implications you can afford, you can buy. By affordance, that is a cognitive science word. And for example, if you see the chair, you know I can sit on that because my understanding my body and the space. Also, you have to reach certain object on the shelf. I can use the chair to climb up. So also doorknob, implying you can pull or grab or rotate. So already physical object or form informing you what you can do with that. So that is a concept created by Gibson, yeah, famous Gibson, yeah, Gibson, yeah. So that is something we want to take advantage of that. So bottle is obvious example. Bottles affording you to open it. So yes.
Your MIT labs also there is the OLPC, and the abacus concept got me thinking on the OLPC and how the OLPC doesn't really, because it's introduced to kids.
Yes.
And the way they interact with the OLPC, it still seems to have a lot of artifacts that the current computer has.
Of course, yeah.
So I was just curious what your thoughts on the OLPC were. I think it should be able
First, OLPC is a great project driven by the vision to make all the kids can access to the computation and information resource on the net. And Tangible has interesting handicap because we come up with a lot of strange physical artifacts which requires soldering, mechanical engineering, all the stuff. There's no simple universal general purpose stuff, except for some stuff like a sense table. So that makes many industry difficult company to jump on, to commercialize, because much more smarter, easier to make a software which web downloadable. Then service can be provided beyond web browsers. But that also gives an advantage because not so many people jump onto this field. So we can really move forward by ourselves. Because once industry catch up, we are out of business because so many strong players. So we have to strike right balance of the high risk, not immediate commerciality or economy, but still there's something essential. So they learn a lot about high-level concepts. Actually, they are applying to certain application, software-based application. But we really enjoy to playing with the atoms and doing a lot of the strange stuff. Like a Pico uses 256 magnets. It's scary amount of the current. And also so much hard work of soldering. No chance of the commercialization. However, in certain foreseeable futures, micro-robot technology may enable all the packs to move. So we can't wait until technology becomes affordable or feasible. We have to fast forward towards the future. Clear what I showed beginning didn't use any digital technology. Everything analog cable wiring. It doesn't matter because somebody make nice digital compression stuff later. But we have to show the value, meaning of this technology for human being. So also my time is running out quickly. That's the reason I can't wait technology come to be available or affordable. Any other comments or questions? Yes.
Have you done any work on using the technology that you have done to assist in restoration of levels of concentration? In other words, if I'm thinking of problem A today, and I advance my thinking to point 10.
Yes.
Now I get interrupted or I have to do something else.
Yes.
When I come back, I cannot get to 10. I cannot just immediately be at 10. I've got to go back down the scale and gradually go to 10, and then I can advance it.
Yes.
Are you looking at using this kind of technology so that you could, in fact, restore the level of education or thought to the 10, so I can start from 10? So,
okay, that's very profound questions. I'm not sure I fully understood, but one of the important difference of the computer versus tangible is computer, once you shut down, all are gone. But the tangible or physical materials is persistent, still stay there. So even you are interrupted, go out to different rooms. When you come back, you can immediately come up to the original context. Stanford, the loft is great because each student can keep using space for 2 years. So they decorate, modify all the space with all the physical artifacts. that also reflect externalized idea. Also other people feel it, all the atmosphere. In addition to Wi-Fi, there's a creative molecule floating in the space. But it doesn't let people jump from 1 to 10. However, externalized persistent representations of ideas everywhere in the physical space surrounding you make a huge difference. Am I answering to your question? Or maybe?
You're answering it in part. You're answering it in part. I was thinking of what new avenues are going to open up when nanotechnology becomes.
Yes. It's great. So when we did a soundscape illuminating clay, we immediately thought, oh, I want to represent the mountain Alps. But the mountain Alps used to be under the sea million years ago. I want to see these mountains can go back to the million years ago. I want to bring the sliders. I want to change all the physical representation. Then we started to make an array of the pin. This is another mechanical engineering nightmare. So many magnets and the soldering. And it didn't work because everything breaks down after the one demo or 2 demos. But we now started a serious project post-tangible bits called radical atoms, because if you're a computer programmer, you can make every pixel dance or sing, writing code. But atoms are very rigid, or molecule doesn't change, or materials never change except for decaying. But we want to send a signal wirelessly. Then I want to change the form or nature, or resculpt or restructure. So this never be happen in my lifespan. But assuming some atom hackers make a breakthrough in 50 or 100 years, then we started the exploration. What kind of product or service we can create? What's an interesting challenge of interaction technique? So nano MEMS, material science, synthetic chemistry, everything is a possible components. But I've just started these directions as a new challenge as a post-tangible bits. Yes?
I'm interested in these displays in very public places like Times Square or
yes.
in cities where that monitor important quantities like the deficits or the number of people killed in a war or the population of the Earth. But these are always given, as far as I know, they've always been given in just digital representations.
Yes,
right?
that's
so
true.
You see a counter which keeps...
That's true, yeah.
And so it doesn't have that much impact because
that's true.
You see just a number there.
That's true.
But I could imagine that if there was something that was physically growing in size, which also represented the quantity itself, that it might have more impact. And have you thought about things like that?
Of course, of course. Understanding the meaning of the number is very challenging. At one of my favorite examples, I forgot the name of the museum, Smithsonian Museum in New York, Science Museum. All the history of the universe is mapped to the spiral.
Science Museum.
Okay, so you start walking about the Big Bang. Then, in the end, tiny spectrum showing the life of the human history, for example. So you walk and you learn all the amazing scale of the history of the universe. So certainly mapping to the space, moving the body, or actuated object is something fundamentally powerful. And also metaphorically, there's an artist who used number of the pseudo-wave cellular phone using a real tiny piece. Who is it? Christopher? Do you remember? There's an artist who really represents the number, important number, with a collection of the tiny like a picture of like a cellular phone, so that first you don't see anything, but you zoom in. Oh yeah, Benson, yeah. Also many students have. Yeah, so it is a powerful representation to make people understand using zoom in, zoom out, walking architecture space, or seeing stuff moving out in relative to your body. Yeah. So I strongly agree that there's a lot of interesting possibility. But now information visualization become very hot areas, like many eyes that the IBM site at the Martin Wattenberg is doing is amazing. But once we transform in a physical domain, it's really great. Also, like a financial pressure might be more appropriate to be felt as a real pressure or heat, for example, or instability of some like a chair you are sitting. And also the economical climate might be more appropriate to be felt as a heat or coldness using a Peltier junction. So certainly there's a lot of interesting mapping of the meaning of the information to a variety of different tactile media is there. So we can make at least 100 PhD theses in coming 10 years if you tackle this project. Yes?
I want to follow up on that question. The idea of the memorial, the Vietnam Memorial in Nai Lin, where people's names were actually inscribed, somehow that made it so much more meaningful. So I'm wondering if Hiroshi can talk about, Dr. Ishii can talk about the sculpture and the tangibility and how that has more meaning. It feels like you're talking about the shape of things, being able to touch things.
Yes, tangible has two meanings according to dictionary. One is you can touch, but the second is it exists, existence. You believe the existence. That's something fundamentally important. I'm very fascinated about archaeology. If you go to the Acropolis in Greece, every 10 meters you can time travel 100 years, and all the artifacts remains etched on the stone. And we believe this stone exists another 100 years, although it might be worn out. So this does not exist in the VHS videotape, which we discussed, or all the digital stuff. Every few years, dramatically operating system architecture changes, then every great contents are left behind, except for very special one. So like an ephemeral, like a temporality of this representation does not really give a sense that permanent. Yeah, so I think still stone is so powerful. Yeah, so I don't know how to bring this stoneness into digital domain. Also another problem is memory and history. Antique chair really evokes all the story lives of the people who use all the scratch. Also, all the book or dictionary you used, or room, hundreds of people lived, leaves capture all the traces. So that is completely missing digital. Of course, you can emulate in a fake way, skin deep visual like worn out, but fundamentally bits is not worn out, doesn't capture memory life. So that it's not so beautiful, it's not so provocative, or it's not really inspirational. I don't know how to do that. So I want to make a new atoms which has all the memory, because memory is now infinite and the price zero, because you can put everything in net. But just atoms, molecules can have the pointers, then have a sensors and maybe certain display. So still very vague idea, but we're still far behind from the atoms, molecules. So I have to really work hard. Yes.
So this is great. So I can't help thinking about the connection with your work and Jerome Bruner's learning theory. Basically, he said there are three modes of learning.
Oh, yes.
There are kinesthetic and iconic and symbolic.
Yes.
I think the message behind his theory was that there are certain things that can be only done in symbolic way. For example, you are talking about solving the Navier-Stokes equation.
Yes.
I guess the core idea of Navier-Stokes equation is sort of symbolic or mathematical, and
yes.
You, I think, are not exposing or make it tangible. That symbolic or mathematical idea of Navier-Stokes equation in tangible way. So, is there any way to really make many symbolic things other like the tangible, touchable, something you can, or the users or learners can touch and use?
I think it's a really great question. And if you run Navier-Stokes equation as a mathematical equation, it's purely abstract, symbolic. But the significant difference, if you really extend your hands, grab the object, then see the moving flow. But even nice if you can feel as airflow, for example, then maybe Bruner's theory really informed the design of this topable. Actually, you saw the snaky motion or phase shift. These are very abstract concepts. But here, we really push the boundary to make very tangible, hands-on physical manipulation. People can learn many high-level concepts which taught in the mechanical engineering through these building blocks and the exercise. So Bruner's inactive and iconic and symbolic. So how to really bridge all stuff, then co-evolve the system involved. So symbolic is not enough. Also, inactive is not enough. So I'm not a theoretician to fully understand this theory, but we got a lot of inspiration from the theory of the learning and the representation. So I think great being a visiting scholar of the symbolic systems program, which made me think a lot about what's the meaning of symbol, what is missing, how we have to combine. Yeah. So hope Topovo address some of the issues. Also, Hayes Raffle, he co-invented the Topovo, just finished a PhD thesis in which he discussed all this kind of Bruner's theoretical framework, how it's informed design. Also, he's leaving Cambridge, Massachusetts, and moving to Palo Alto. Yeah. So I lose all the good students who go to California, but he can hope he can join this class and teach his experiences. And he's a great guy, philosopher, artist, and a designer. Any other comment or questions?
Okay, thank you.
Thank you very much.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.